Alright, welcome back again on to another video of 100 Days DSA Mastery course. And this one we'll be talking about Heap Sort Algorithm. So, what exactly is Heap Sort? We'll see that, we'll see the advantages and disadvantages, and also we'll see the steps of performing a Heap Sort algorithm. And afterwards, we'll implement it practically using Python programming language. So, let's just get started with the definition of it. Alright, so heap sort is an efficient comparison-based sorting algorithm that uses binary heap data structure. It is known for its reliable performance, especially in large data sets, and is often used in applications where memory usage and stability are important consideration. So it's like basic English. You can just understand what I'm trying to say. It's a comparison-based sorting, which means it compares. It takes one element as its key and then it starts comparing all the elements with it, and whichever elements are smaller than it will be on the left side and bigger or larger will be on the right side. That's how it works. Simple as that. It works on binary heap data structure. So it's pretty simple. So let's just see the steps of performing a heap sort algorithm. So the process has just 4 simple steps. The first you do is build a max heap, swap the root with the last element, then you heapify the reduced heap, and then you repeat the process. That's how it works. So first you build a max heap. What you do is convert the input array into binary max heap where the largest element is at the root. Simple. Then what do you do next is swap the root with the last element. You swap the root of the heap with the last element of the array, right? Effectively removing the largest element of the heap, right? Then what do you do the next process? In the next process you do is restore the heap property by heapifying the root element of the reduced heap, and then you repeat the entire process. So let's just do this practically so that you can at least understand what I'm trying to say. But before that, let's just take a look at advantages and disadvantages of it. Advantages, as always: efficiency, space complexity, no worst case degradation, non-recursive, and then what else do you have is no external libraries are needed. Simple as that. Now when it comes to disadvantages, all it has is less stability, then cache performance, complexity, and initialization overhead. So these are the very basic things which don't need a huge level of explanations. And yep, so let's just jump on to the practicals of it and see how this actually works. Alright, so as always, what do we do as the first thing? The first thing we do is create a function. So let's just create a function. Alright, so once we create a function, so basically we have to create 2 functions. And the first will be heapify and the second will be heap sort, right? So the first one we do just the basic stuff, which will be pretty much like sortings and stuff, right? So heapify will be all about just sorting the stuffs, and heap will be understanding what to sort, right? Because we are gonna like run multiple loops in the heap sort. We have to run two sortings consecutively. All right, so let's just say left and right, and if the left of n is greater than the left of array of left, then largest and blah blah blah, then the largest will be okay. If this condition is true, then the largest will be have the value of left. Left will be assigned to largest, and if this if the n is larger than the right side, then the largest will have the value of right. Simple as that. It's not too complicated. We're gonna keep it very simple, not too complicated, so that would make more sense for it. Alright, so the largest will be assigned right, and then we'll see if the largest does not equal to I. Then what we'll basically do is just swap both of those variable I with the largest and largest with the I, and that's it. And then we're gonna do the recursion, like we're gonna execute again the heapify function by giving it the values of array n and the largest. That's how it is. All right. Heapify array n and the largest. So n basically is the length of the array that we are going to define in the later on function, which is in heap sort, right? So let's just define it real quick. Define heap sort, right? Let's just do that. Array, then n equals to length of the array. Then what we'll do is we'll run two different for loops, one to execute our heapify and another also to heapify, but prior to that we'll just swap the elements. All right, so it will start from n by 2 minus 1 and go to -1, and it will take the steps of -1, so it will just keep on minusing 1 1 1 1 index at a time. That means step. So first thing is initialization, and then there is the endpoint, and then there is the increment decrement. For in range, exactly the same thing. Okay, starting endpoint, and then there is the number which we are going to be heading towards, and then there is the swapping stuff, like the I0 0 I, and then we'll execute the heapify function again. So heapify can be a little bit complex because it's like based on too much of recursion stuff. So I don't usually suggest you to use the heapify heap sort algorithm. You can use different algorithms. We have already studied like 6 algorithms so far, and we're going to complete like 10 different sorting algorithms only. Searchings and all of those are different things. 10 sorting algorithms, and the one that I don't suggest mostly to use is heap sort. It's like crazy, it's weird, but once you master it, it's kind of easy to go with any other algorithm because it's too complicated. And once you do the hard thing, anything less than that seems pretty easy. So let's just run this. We are done with it, and largest will be the I think it's pretty perfect. No errors, done. Just run it. 6-1. Bye. Alright, so now you can see we have entire sorted array ready. So this was all about heap sort algorithm. Thanks for watching. See you in the next one with some new algorithm.